Hi, good morning. This is Mr. Crinier. So I'm going to talk about benchmark number 26, proving parallelograms. And there goes my little boy making funny faces. So in the last lesson, we recognized and applied the 4 different properties of parallelograms. I encourage you guys to look back at the old videos, take a look at benchmark number 25. Okay, today we're going to go ahead and recognize the conditions that ensure a quadrilateral is a parallelogram. Alright, welcome back. We're going to go ahead and talk about this first condition for parallelograms. Alright, so let's go ahead, let's take a look at this. If both pairs, so I'm just reading over here, of opposite sides of a quadrilateral are congruent. So if this side and this side are the same and the opposite sides here are congruent, then we can safely say that that quadrilateral is a parallelogram. So I want you to take some time to think about that, and then if you have any questions, let me know. Our second condition for parallelograms. All right, this is going to be 610. Now, if both pairs of opposite angles, so let's say angle D, angle B, if they are congruent, again, it has to be both of them, so angle A and angle C. If they are congruent, then we can safely say that the the quadrilateral is a parallelogram. If you have any questions with this second condition, please let me know. Okay, welcome back. This is the third condition for parallelograms. Now let's look at this. If the diagonals, so from A to C, and from D to B, if they bisect each other, and those segments are congruent, then this quadrilateral is a parallelogram. Now, once again, if you have any questions on this particular condition for parallelograms, please let me know. Alright, welcome back again. This is the last condition for a parallelogram. So let's say if one pair of opposite sides is both parallel, and here's the notation for parallel, and congruent, then we can safely say that the quadrilateral is a parallelogram. Again, let me know what you think, and I'll help you out with that. Example number 1 on identifying parallelograms, benchmark number 26. So let's go ahead and let's work this out. Let's see if we can answer their questions here. Determine whether this quadrilateral is a parallelogram. And then we want to go ahead and justify our answer. So the first thing that I notice here is that you have a segment 20 here and 20 here, so both of these are congruent. I also notice that this segment and this segment also carry same number, 35. So I can safely say, based off of that first condition, if the opposite sides are congruent, both pairs of opposite sides are congruent, then we can safely say that this is a parallelogram. So we'll say, first of all, we'll say yes. And then we'll say, well, we want to justify our answer. So I'm looking at my notes, and I can say this: if both sides are congruent, and I'll use a shorthand for this. Both sides are congruent, then I can safely say it's a parallelogram. Alright, if you have any questions, please let me know. Alright, thank you. This is your chance to solve to see if you understood some of those prior conditions. So which method would prove this quadrilateral is a parallelogram? A, both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. One pair of opposite sides, both parallel and congruent. So go ahead and take your best choice, and we'll move on with this question. All right, this is example 2, benchmark number 26. I'm going to use parallelograms to prove relationships. So scissor lifts, like the platform lift shown, are commonly applied to tools intended to lift heavy items. Okay, in this diagram, A and C are congruent and B and D are congruent. Now explain why the consecutive angles will always be supplementary regardless of the height of the platform. All right, in order to explain why the consecutive angles, we'll say angles B and angle C will always be supplementary. What I know is that A and C and B and D are opposite angles, and they're both congruent. So I know that ABCD is parallel. So we know that that's parallel, actually a parallelogram. So since ABCD is a parallelogram, I know, based on some of the terms we talked about in benchmark 25, since it's a parallelogram, we can safely say that angle B and C will equal 180. So the first thing you want to do here is just make sure you know that ABCD is a parallelogram. Since you know that, based off of what was given, we can say that B and C are going to be supplementary because it's a parallelogram. All right, let me know if you have any questions. I can probably help you out with that in class. Diagram, it shows a car jack. Here goes the support from the ground. There goes the weight from car. And there goes that crank. All right, the diagram shows a car jack used to raise a car from the ground. In the diagram, A and D is congruent to BC, and AB is congruent to DC. Based on this information, which statement will be true regardless of the height of the car jack? Angle A and B are congruent. Angle AC are congruent. Angle AB is congruent to segment BC, and angle A plus angle C equals 180. So which best describes this diagram right here? All right, let me know if you have any questions. This is example 3, benchmark number 26. We're going to use parallelograms and algebra to find values. So we want to find x and we want to find the y values, so that this quadrilateral is a parallelogram. So let's go ahead, let's start. So we know that this side and this side have to be equal. So let's go ahead, write that equation, 4x minus 1 equals, let's distribute this 3 times x, and then 3 times 2. And we want to go ahead and collect our terms. Let's subtract the 3x. Same thing over here. Here's my x minus 1 equals 6. And then I'm going to go ahead and add 1 to both sides. X equals 7. Alright, so that'll be my first answer. And then I want to do the same thing on this side. So I know that 3y I'm going to distribute this. Has to equal 3 times 1 is 3. And then I'm going to do the same thing over here. 4y minus 2. I'm going to collect my terms. Move the 3y over. And let's go ahead, minus 2. This is an equal sign, not a plus. And I'm going to add 2 to both sides. So there goes my 2 answers for x and y. I can go ahead and plug it back in and see if it's going to equal out. 4 times 7 is 28, minus 1 is 27. And I know, let's see, 7 plus 2 is 9, 9 times 3 is 27. So this is good. And then 5 plus 1 is 6, 6 times 3 is 18. I'll do the same thing here. 4 times 5 is 20, 20 minus 2 is 18 as well. So x is 7, y is 5. Let me know if you have any issues with the algebra and setting the problem. Okay, welcome back. This is the guided practice. I want you guys to find m so that the quadrilateral is a parallelogram. Is it going to be 2, 3, 6, or 8? Show your work on the dry erase board or your notes.